Good afternoon, ladies and gentlemen. Thank you very much for joining my presentation this afternoon. My name is Aidan Metcalf. I'm from Surrey Nanosystems in the UK, and I'm going to be talking about Vantablack light absorbing coatings and how they can be used in a range of industries to add to performance. The name Vantablack is a brand name used for a range of super black coatings that were developed by Surrey Nanosystems. Some of you may be familiar with the name Vantablack. It became well known when Vantablack was when we developed the world's darkest material. It was 99.96% visible light absorption. So it held the world's record for the darkest material on the planet at one stage. And using this technology, we've been able to develop a range of products for different industries to fit with the requirements for things like space, automotive, and the LED screen industry. The technology is largely the same. It carries over from one industry to another. We're using the base technology, which is a carbon microstructure that is applied to a substrate. And whenever this carbon microstructure is developed, it's highly effective at absorbing light. If you look at the slide or the picture on the left, you can see the carbon structure under a microscope, and it looks almost like a coral structure. This structure is highly effective at absorbing light, not only when the light is perpendicular to the substrate, but as the angle of incidence increases, you find that the light absorbance continues. And if you look at the comparison chart on the right side of my slide, you can see that as the angle of incidence increases for a standard matte black coating, the level of reflectance increases significantly. Whereas with Vantablack type material, the level of reflectance stays more or less the same, increasing very, very slightly. So you're getting an almost perfect Lambertian surface with the Vantablack material. Now, Vantablack was first used in space in December 2015. And in the space industry, they use baffles to try and suppress unwanted or stray light from entering optical instrumentation in space. Whenever these baffle systems are coated with Vantablack technology, it allows the designers to reduce the size, complexity, and weight of the baffles, and at the same time increase the level of performance. So this is a major step forward and allows for reduced weight and therefore maximizing the efficiency of the payload. So it's a key benefit for the material. The material is also used for the calibration black body calibration systems, and these are now approved for use in space also. The baffles that went into orbit in December 2015 spent more than 8 years in orbit. We've had several test systems in space since that, and Vantablack materials are now qualified for use by the North American space missions and European space missions to be deployed on both large and smaller baffle systems and calibration black bodies. Now, the optical performance is one thing, but there's a range of features that need to be obtained by these materials to allow them to be used in space. To withstand a typical launch, it has to have a resistance to significant vibration, obviously, and shock and vibration. We have also really wide range of temperatures that these materials will be exposed to in orbit. They can go from something like minus 200 degrees centigrade to higher than 100 degrees centigrade. So they have to be resistant to major fluctuations in temperature. Also, we have a need for UV stability. Obviously, in space, the level of UV is highly intense. And so the stability in UV is extremely important. And these materials, being carbon-based, are extremely stable and resistant to break down UV, which isn't the same for a lot of standard coatings. So they're extremely UV stable. So that's a use that they have for space systems. Going back to, for LED screens, the challenge there is to maximize contrast between LEDs and the background, or the area behind the LEDs themselves. So to maximize contrast, the LED manufacturers or the screen manufacturers want to have like a black coating, but the industry standard at this point in time is a simple matte black coating. And if you have a look at the pictures on the right side of my slide, the top picture here is a screen in the US that should effectively be black. But if you have a look at this area here, you can see the reflection of a screen from the opposite side of the street. Obviously, that's impacting the quality of the image. And the picture below is from Times Square in New York. And here we have these are some of the most expensive advertising billboards on the planet. And here you can see that in strong sunlight, the images are very poor quality. So the directors of these organizations are not going to be very happy spending the millions of dollars that they spend to see that the images get washed out in strong sunlight. And one of the mechanisms that the screen manufacturers use today to try and compensate for this fading of the images is to increase power consumption, which runs counter to everything that they're trying to do, because their function at the minute, or some of their R&D functions, are working on mechanisms to try and reduce the power that is consumed by these systems. So from a sustainability point of view, they want to be able to reduce power consumption, not increase it. So Vantablack Vision has been introduced to be used this material can be applied by spray to the normal masks that surround the LEDs. And by doing this, we can move from something like 10% reflectance in some cases down to something like 1.5%, which is a major step forward. In these cases, we're seeing a significant improvement in color depth and definition, and in favorable lighting conditions, some of the manufacturers can believe that they can reduce the power consumption and still maintain the quality of image. So that's a major step forward for the LED screen market. And these images, you can see the screens are contrasting Vantablack, the top half of the screen, and a standard matte black coating at the bottom. So you can see in these on this demonstration screen the difference in performance. Moving again to the automotive industry, and with the increased use of advanced driver assistance systems, there's a need for improved quality and clarity of the images that we're picking up, either in heads-up display units or even for the LiDAR systems, or the light detection and ranging systems. The quality and clarity of images is obviously extremely important. But if you have a look at the images here on the right again, you can see that in a heads-up display unit, when the light is at a certain angle, that you're getting ghost images, which is sort of making it's interfering with the clarity of the image that the driver is seeing. And if you have a look at the camera or the picture on the image below, this is a forward-facing camera at a particular time of day, on a particular angle of sunlight, when the glare shield itself is reflecting into the lens and therefore interfering with the quality and clarity of the image. The objective really is to maximize the quality and clarity of image by using the appropriate coating to remove that stray or unwanted light and minimize that glare effect. And if you have a look at the image on the right-hand side, the lower one, you can see that we have contrasting images. One here is a standard matte black coating on a glare shield. The other has been coated in a Vantablack coating. So you can see there's a massive difference between standard matte black materials and genuine light absorbing materials such as Vantablack. So this is now being adopted into the automotive industry, and we are working with some major manufacturers to develop these systems. In this short presentation, all I've given is a flavour for the industries where we can add some value. The roots of our technology was in the space industry. Now it's used across a wide range of industries, from automotive to LED screens, to various optical instrumentation, and many more industries besides. Thank you for your attention, and I can possibly take a couple of questions, or I can be contacted via our website or via the Photonics platform itself. So thank you for your attention.